You can expect programming questions on there.
in Python.
What's this? Oh, but you have a 2-hour final. So I could design the exam to take 4
Oh
hours,
my gosh. Okay. Wow.
and then you have to compress it into 2.
Yeah. Write a program.
Usually, I write my final exams to be the same length as the midterm is. You just have 2 hours to take it instead of the 50 minutes. So it should not be a time constraint thing. So if you don't do well on it, it's because you're not good at the stuff yet, not because you were cramped on time. So same length as the midterm-ish. 10 questions designed to be about a 50-minute exam.
Is it possible you use midterm questions on the final?
Probably not the identical questions, but something maybe similar. Because the final will focus on what we've done since the midterm, but you're still responsible for being able to create variables, writing loops, kind of the fundamental programming stuff. If you didn't notice, I still need to put up the exact topics, but extra credit opportunity for the final exam. And remember, my policy is that if you do better in the final than you do on the midterm, I'll replace your midterm grade with your midterm exam grade with your final exam grade. So this extra credit could stack. If you get an 80 on the final, plus you can get up to, 10 or 12 points? Whatever it is. Let's say it's 10%. It might be actually 12%. But you attend all the talks next week, it was on Slack, which I'm sure half of you read and half of you didn't. Raise your hand if you know what I'm talking about. We got a little bit better than half, but yeah. In any case, next week on Tuesday and Thursday is senior seminar presentations. So these are the seniors graduating from computer science this semester, or hopefully graduating this semester, and they have a semester-long project representing 300 hours of work. So computer science majors will be doing things that are 75% creation, 25% using things that have already been created. IT majors will be 25% creation, and then 75% using things that have already been created. And these are real-life kind of should be enterprise-type projects. And they'll be giving 30-minute presentations next Tuesday and Thursday. It's from 5 p.m. until 8 p.m., both of those nights. And it's in the pharmacy building, I think room 026, something like that. Mm-hmm. And I'll put up the exact topic. So best thing for your grade is to attend all of them. But if you can't attend all of them because of work responsibilities or whatever, that's just the way it is. Ask for time off of work to help your grade. But if not, it's nothing I can do about it. Whatever. That's not my problem. Just decide what's important to you, and you're adults. So in any case, for every one presentation there'll be a sign-in for each presentation. So every one presentation you attend, that'll be 1% extra you'll get on your final exam. So that means if you had an 80 on the midterm and you got an 80 on the final, and that 80 becomes a 90, now you replace your midterm with a 90. Make sense? So this can only benefit you. Some of you could probably benefit from that, so you might want to clear your calendar for next Tuesday and Thursday night and sit through 6 hours of presentations. Exciting stuff. I mean, some of it's pretty good. Some of it, yeah. Yeah, you can bring. I mean, it's in the pharmacy's big lecture hall. Yeah, bring food, bring drinks, whatever you want. It's a very informal thing. Huh? Well, it depends. I have to know about the pizza ahead of time. That way I can work out extra so I have extra calories left over. Like, that's why I need to golf this afternoon instead of go home to get a contact, so I have calories for the pizza thing tonight at the VR demonstration. This is all a thing. Yeah. So, but you bringing me a pizza at the senior seminar things is not going to earn you more extra credit than the 1%, but it might put you in my good graces if that ever benefits you. If at some point in time you're on that borderline and I'm deciding, well, do I kick him to a B- or keep him at a D? All right, so we did not have homework, correct?
Correct.
All right, just the quiz. And last time we were writing what were we writing? Oh, that is blurry. All right. Okay. I was in the process of kind of explaining where this main thing. came from, right? Okay, so I think I showed you some old school programs, and what did I write? I wrote this hello.c. So this is a program that would have worked in 1970. Okay, program that would have worked in 1970, and so notice we have a function here called main. It takes in two parameters. This first parameter is the number of command line arguments that were passed. The second parameter is the actual command line arguments that were passed. And what I mean by command line arguments is if I come out here, let's just do my ./hello. That was my compiled C program. If I say A, B, and C, those are command line arguments. So those guys will come in as three strings, A, B, and C. So argument count will actually be 4 in this example. First argument will be the name of the program. Second argument will be this guy. Third argument will be this guy. Fourth argument will be this guy. All right? So in the program here, argc is the number of things that were passed at the command line. These are the actual things that were passed at the command line. This isn't something that modern programmers really use very often because now all of our programs are, you double click an icon and it launches the thing and the magic happens, right? But historically, and you've seen me do some of these things out here where I'm typing things and, so for instance, if I want to, ls shows me all the things that are on my screen. If I do ls pipe to grep for star.py, something like that, I don't have any. I have py things on there. Let's just do a py. So there's my py thing. So this is taking this program and it is sending the output of that to this program, which takes a single command line argument called, in this case, py, and that's the thing I'm searching for. Okay, I'm searching for things that have py in it from this big list of things that came out of here.
Okay.
All right. This was a very common way to use programs back in the DOS and Unix days. Okay, we're not living in that world today very often. But an important thing, I think I brought this up earlier in the semester. So out of curiosity, how many of you are IT majors as opposed to computer science majors? All right. Only 3 of you. That's actually exciting. So the rest of you are CS majors? Oh, man. I like that. Usually it's more of a half and half thing. So now one thing we run into, and I think I mentioned this first week of class, is there's this common conception that people have that computer science is the real thing and IT is like the computer science for dummies thing. It could not be further from the truth. Okay, those are 2 completely different skill sets. And a few minutes ago you heard me mention something that computer science, I said this the first week as well, is about 75%, let's call it programming, creating new things, and 25% using things that have already been created, third-party APIs, talking to databases, things like that. Where IT is 75% of the time using things that have already been created, and then 25% of the time programming, scripting, writing things that you're creating a brand new solution to something. Now, this command line stuff, would we say things like this feel kind of intimidating? Especially from a modern computer user, we're not used to it, right? We spend our whole lives drag and dropping, double clicking and stuff like that. It's going to be far more common for an IT professional to have to do stuff like this, okay? And have to write programs that run in an environment like this. Because keep in mind, they're having to take all these tools that already exist. They run into Home Depot, okay? They have a project they have to build. They have a problem they're trying to solve. And they got to bring a bunch of tools home and then connect them all together. And some of their creation pieces are going to be writing the little scripts that makes this guy talk to this guy. So the actual program they're writing might be, from our perspective, kind of simpler, because it's just passing information from this guy to get these dudes talking, because they weren't made to talk to each other. All right? But they don't get these nice little graphical user interface tools where they can hit play buttons to test stuff out and things like that. Instead, they might be writing some software that's living on some managed switch that's under the floorboards halfway across campus, for example. Okay? They're sitting in their office, remoted into that machine, and what they see looks like this. Okay, so they're doing their editing using an old school text editor or something like that. They have to write things like I'm typing here from the command line. They're learning a skill set that is kind of an old school skill set, but we see that most of our technology infrastructure is built on the things that have happened over the last 50 years. right? And if something's not broken, why fix it? Right? We have these things called switches and these things called routers, and they exist today, they existed 10 years ago, they existed 30 years ago, blah, 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 blah. Make sense? So who knows what age of stuff you're using, and if it's not broken, why fix it? Because effectively, what's a router? It's a box that has fans on it to keep it cool, that has a whole bunch of Ethernet cables plugged into it, and a bunch of blinking lights. And inside of it, magic happens. Okay, that makes sense? So the IT professional, I think it's more common for an IT professional to have some of the CS computer science skill set than it is for a pure computer science person to have some of the IT skill set. A good example would be my wife. My wife is a computer programmer. She's been a COBOL programmer for almost 20 years now. So very computer science, well, actually very old school computer science. So she actually does things like this because COBOL is super old. So she's remoted into a mainframe computer somewhere. So that side of it is maybe a poor example, but let's pretend like she's an Android programmer where she's using these nice tools where she hits the play button and you want a button in your application, you drag the little button from here to here and you say, I got a button. Okay? All nice and easy like that. Okay? If how many of you have ever set up a Wi-Fi router at your house? You need to give yourself a wireless internet. You have a cable modem, so you bring it home pretty easy to set up. Okay? She wouldn't even try to open the box. Okay? Completely out of her comfort zone. She doesn't want to mess with IT type of stuff. So she's very much computer science, but that's her job. That's what she does day in, day out. She writes software. She doesn't have these other skills. I mean, she could probably follow the directions, but it would take her 2 hours to put the thing together. Okay, where most of we rip the directions up or just lose it with the box, and then you realize there was a cable in there you really needed, and now you got to go find that cable. Okay, but the punchline is that I think it's more common to have an IT person who dabbles in programming than it is to have a programming person who dabbles in IT. Now, some of us were hobbyists too, right? So you kind of started off when you were in high school or junior high, you were building computers and messing around with stuff because that's what you had your hands in, right? You could just mess around with plugging things together and making stuff work. So you kind of learned your IT skill set from playing, right? You just messed around with stuff. Well, so, I kind of want to encourage you who are IT majors. I'm actually very surprised that we have this kind of divide. Usually it's more of a 50-50 balance. But don't let anybody ever tell you that you have a lesser degree. Because in many cases, you're going to be actually the harder worker. The computer science person can do their job with their underwear. Okay? You're going to be laying in some basement somewhere, hooking wires up. Probably don't want to do that in your underwear if you're an IT person. Okay? So show respect for our IT guys. We hear the same thing here on campus. What do we say? Whenever the internet is down or something's wonky with the Wi-Fi or something like that, guys in IT, they're incompetent, right? That's what everybody starts screaming and stuff like that. Okay? They're not. Okay? They know what they're doing, but when you got a whole lot of students all trying to steal movies and running BitTorrents and things like this, and so now when everything's working, nobody says they're doing a great job, right? Okay? It's like, well, they're just doing their job. Okay? When stuff breaks. Who are these people? They just hired from Hardee's? Get what I'm saying? Yeah, it's kind of like being a president or something. When you're not doing your job, you get screamed at. When you're doing your job, well, that's your job. Okay? Computer science guys don't typically have that kind of pushback. Like, oh, we write software. Here's your beta. Test it. It's like, well, this doesn't work. Okay, I'll fix it. Nobody says we're incompetent. So remember your IT people. Next time you're complaining that your PS4 won't connect to the network for something because a port is blocked. That port's probably blocked for a good reason because you're also running a BitTorrent server in your room. So, it's like they have to lock down the whole network so you guys don't bring it to its knees. Which part of which part? All right. So even the faculty aren't allowed to use. We can't have extra switches and Wi-Fi routers and stuff like that. At least not that they can find. If If you've been in my office, next time you're in there, why don't you gaze up at the ceiling? You'll see some wires going up to the drop ceiling. And there's some stuff up there. All right, so swinging back into this. So this was kind of this idea of these command line arguments from a long, long, long time ago. Okay? Pretty common for programs to take those types of things. It's not unheard of today. It's just less common. So from an average technologist type perspective, you might go through your whole career and never have to deal with this. It actually has somewhat become maybe more common today to have to work from the command line here, especially if you're a web programmer type person. I know a couple of you have done some of that stuff, whether you've done Node.js or Ruby or Python. Remember when we talked about those guys, we talked that some of them have like package managers. So Python has a package manager called pip. Ruby has a package manager called gems. Gem. Is it just gem? I think it's gem. And then Node has one called npm. But regardless, you would type something like npm install, make up a package name, and it's going to go out and it's going to. Is there really something called blah? Oh, it's updating. It actually is something called blah. I have installed package blah 3.2.2. I have no idea what that package is. Okay, but I've just installed something, Node.js package in here. It is deprecated, by the way. Oh, that's this other thing. This is the JavaScript library. It's very interesting. But in any case, you might run into things like that where you are writing stuff in the command line to bring libraries into your code and stuff like that. So you don't get to completely avoid it, but it's not part of our normal everyday. Like everybody in here, regardless of how good at programming you think you are today. And remember, many of you are supposed to still suck at it. Just keep that in mind when you're working on your homework and you feel like, I don't know what I'm doing. Now, if you get to your senior year and you still suck at it, then we should probably talk. All right? But for some of you, you leak through this class and maybe halfway through next semester, you feel like, why was that ever hard? Okay? It just kicks in for different people at different times. Kind of like the whole, didn't Michael Jordan not make his high school basketball team or something like that?
Yeah.
Yeah, but they ended up doing okay in the pros. Okay? It's that kind of thing. So, try not to let it discourage you as you kind of work on your homework and feel like you're just terrible at it. But there isn't a way around that. You just have to keep throwing hours and effort and tears and disgruntlement at that type of thing until it finally catches. If I could make it easier for you, I would. But programming is hard. It's just the way it is. Cope. All right? But in any case, every single one of you, regardless of how well you think you can program, you can double click on a program and open it up. You can hit the start menu. You know how to browse through your files on your computer. There's a whole bunch of canned skills that make you way better at using a computer than grandma, right? That you don't give yourself credit for because it's second nature to you. You've been doing it your whole life. This stuff here is the same thing for people like my age, where we started with computers that didn't have icons. Started with computers that didn't have a mouse. Okay. And I have used a computer that also didn't have a keyboard. You'd actually have to go up with vacuum tubes and turn things on and off, but that was more of like at a museum type thing. That wasn't during my specific lifetime. Dr. Locklear, maybe. I think probably he started off with the stone tablets, okay, and then the abacus, and then maybe had the vacuum tube thing. And then, oh yeah, I did the punch cards. Yeah, those are. You start off with just sticks, you draw in the sand and the dirt.
The original apple, an apple from a tree.
Who wants an Apple 1? We can have the Apple 0. You just walked. Program this.
Make 3.
All right. So we kind of get this idea that this main thing is something that's kind of left over, and this supports that slide we had that kind of showed the history of our programming languages way, way, way back when. Whatever, should have this guy right here. Way here at the top, we have this guy C. Okay, let's call that 1968-ish. Okay, before all of us were things. Okay? Dr. Locklear was a thing. Then, yeah. Old. You know, it was his birthday yesterday?
Really?
Yeah, you should go by his office and wish him a happy birthday. Yeah, at some point. But
Okay.
on his Facebook page, I just replied, we usually say happy birthday. I just said #old. All right. Oh, wrong guy. Okay. There we go. So, in any case, if we go back in here, this is a program that would have printed out Hello World in 1968. Now, when you look at that, it doesn't look that foreign to us, right? Mm-hmm. There's some weirdy stuff in there, like the star thing. That's a list of strings in Python speak. All right, this is a list that's made to hold some strings. In C, this is a pointer. We know what pointers are, right? They're variables that hold memory addresses. This is a pointer that points to the beginning of an array that holds a bunch of pointers to characters. That is the first element of each of those strings. So this is an array of strings, is what this ultimately does. And so you have a thing that points here, and then each bucket of that guy points to a different place in memory where those strings live. Okay. All right? Not that important that we understand that right now, but just understand that something from 1968 still makes sense to us today. Okay? And because we had a main way back then that took in command line arguments, and if we look at our Java version of this, didn't I have a... There, well, let's go out here. I must have closed it for another class. It was taking up too much space. Oh, I need to finish typing Java, right? It's like, what? All right, so here's our Java program right here. Does this guy look fairly similar? Here, let me actually, let's just do this. Here's 1968, and let's just call this 1994, something like that. Okay, we have void main, so we still have the main thing. Now, this guy takes in an array of strings. That's what he takes as a parameter, just like this guy took in an array of strings. Now, why did this guy have two parameters where this guy only had one parameter? Does anybody in here happen to know? This kind of shows us the evolution of our languages. In Java, just like we have in Python, so we're going to say arrays and lists, kind of same kind of animals for us right now. Let's think about it like that. All right, so in Java, just like in Python, a list or an array knows how long it is. It can return its length. Okay? We can say, give me the, in Python, we can say lens, parenthesis, pass in the list, and it'll tell you how many elements are in that list. In Java, we can say args.length, and it'll tell us the number of elements in that array. That doesn't exist in C. So in C, it had to take in the length and then the actual thing. So arrays back then weren't able to tell you how big they were. In C++, that was sort of kind of added with this function called sizeOf, but that was still kind of funky. But we're effectively looking at the same main here as we're looking at here. We just only needed one parameter because this one parameter can give you both of the pieces that you used to get. That make sense? So this comes back to this kind of this overarching statement, we might say, and we might have in our notes already. But let's just talk about main. All programs begin and end with main. Okay? All programs begin and end with main. So that means when you start your program, when I run my Java program out here, and I say Java hello, the very first thing that Java virtual machine does, this guy right here, is he calls the main method of this program. And the main method, in this case, just said print hello world. But that main method could start calling other functions, could start creating objects. So if we look in here, our main method in here, what does it do? It creates a variable. It creates another variable. And these variables are leveraging our objects that are living up above, right? Other parts of our program. So I'm building Blaine, which is a player, and that has a whole bunch of crap associated with it up here. So that's all the player logic. So lots of scary stuff. What's this an example of when we hide all this scary stuff inside of a class? What's that an example of? Could have been a question on the quiz.
Oh.
Encapsulation. Good. Yep. So that's an example of encapsulation. So our main method here, this guy is creating a couple of variables using these variable types that we built, right? We built players, we built fights, this kind of stuff. It's also creating a variable that holds a fight object. We built it, so whatever that means. And then we're using that variable to call that fight object's fight function. So we start in main, so we do this first, then we do this, then we do this, and this is going off someplace else in the world to call the code that lives inside of these guys. And then finally, we come back to main, and we are using this variable to call this thing, which lives somewhere else in the world. Right? So main is kind of our the orchestra, the conductor. Main's kind of the conductor for our program, where it says, now do this, then do this, and do this. And some of those things might be very local. For instance, print hello world happens right there, except we're leveraging some function called print that some smart person wrote at some point, right? Because we certainly didn't write print. We just rely on it printing crap to the screen. Mm-hmm. Okay? So, when we just say this, we say print hello world like that, we came up with this. We said, hello world's the thing that we want to print. I just happen to know that this tool that I bought a while ago at Home Depot, if I throw that thing a string, it'll print it out to the screen. I have no idea how it accomplishes that, but I have access to it somehow magically. Okay, it's in the toolbox. You bought it, already paid for. Okay, but I'm effectively diverting control. The conductor is saying, you over here, violinist, start doing something. Okay, you go and you print this thing. Play those notes. Does that make sense? All right, so all programs begin and end with main. So that listed in that was in C, that was in C++, that was in Java, that's in C#, that's in Swift, that's in Python, that's in Perl, Ruby, all these different things. Now, a lot of those scripting languages can be used in a generic main is generated for you way. Okay? So for instance, up to this point, we've just written all our code in the file. And then we call Python 3 on it and just does it. Because what it's doing there is it's generating a main for you because you didn't generate your one yourself. Because notice when we go to our code here, I'm asking this question. So there's this variable called underscore underscore name underscore underscore. That's automatically, we didn't define that, right? This is some variable that's automatically generated for us. And we're asking, hey, is your name main? Are you that guy, the guy that was automatically generated for us? If the answer is yes, then I'm going to say, do all this crap. That make sense? All right. So at this point, we're starting to become more kind of structured in our program because we're doing more than just linear stuff, more than procedural type programming where we're just saying do this, 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 and this. We might call that scripting. Okay, if we're talking about programming from that perspective, we might call that a scripting language where we don't really need to think about main because we're not going off to other places. It all just exists right there in front of us, that type of thing. But now, to start connecting some of those dots, we're going to throw main in here because you're going to very quickly, when you start getting into other languages, start seeing main. So now next semester, when we start working with Java, we're going to start using a tool called Eclipse, which is just going to be writing. We're going to use Eclipse for probably 3 or 4 weeks, something like that, where we're going to be writing programs kind of similar to what we're doing here in Python, kind of getting used to the conversion between the Python syntax and the Java syntax. How do you declare variables? How do you ask questions? How do you do repetition? That kind of stuff. And then we're going to move over to another tool called Android Studio. And we'll start writing Android applications, which uses Java. Because at that point, we're learning a second skill. Now you've converted your Python knowledge to Java syntax. And you've seen that happen in class with me sometimes, right? Where I'll start writing something with syntax from another language. And then I got to kind of bop my head back into Python mode. And sometimes I do it in, because since Python doesn't have the semicolons, if I'm teaching C in 450, I start for the first 10 minutes, I forget to put semicolons at the end of the lines. where C requires that. Sometimes you see me use curly braces instead of the, colon and then indent type stuff. That's just the differences between these languages. So you kind of get into this mode of bouncing back and forth, back and forth. In your job, you very well might program in one language 95% of the time. In my job, I program in many languages on a daily basis. And I enjoy that, but that's like almost my hobby. So it doesn't make it any harder. It makes me fairly well versed in all these different languages, but it also makes me kind of uniquely qualified to say that they're all the same. Right? One's not really more limiting than another. You might enjoy the syntax of one language more than another. In fact, I think I've advertised before why I like Python so much for a first programmer. What did I say? Why is Python such a good language for a first programmer?
Very precise.
No, all programming languages are precise. It has to do with one thing. What you're looking at on the screen here is a good example of it.
Requires indentation.
That's it. Forget about the language. Forget about all this other crap. The fact that Python requires you as a programmer to think about how you format your code. Because I can't tell you when we used to teach C or C++ or Java as a first programming language, beginning programmers have all this stress on top of them where they're worried about, is this going to work? Is this, that, and the next thing? That they make all their code left justified. And then it's so hard to debug because you can't see where one curly brace starts and one curly brace ends because it's just all stuck there left. Or they put a whole bunch of stuff on the same line because they're copying and pasting things into the code, and sometimes it doesn't have the carriage return in it. And those languages like Java and C++ and C#, they're fine with that. You can write your entire program on one line if you want to. That's why you separate statements with those semicolons in those languages. But it doesn't train you to format your code in an organized way. Python does. If Python didn't do that, I wouldn't think it's any better than any other language, really. I think that's the most important thing. It's a good language. There's nothing wrong with Python. Personally, I don't really like loosely typed languages that much. As a first programming language, I wish it was a strongly typed language. I think it's easier to learn strongly typed languages first and then appreciate a loosely typed language. Because then what ends up happening is every single time you create a variable, you have to go through that process of asking yourself, what kind of value is this variable built to hold? In Python, we aren't forced to do that. We can just create a variable and put whatever we want in there. And 5 minutes later, we can put a new kind of thing in there. Python doesn't care. Right? But from a learning programming perspective, it's very important for us to logically consider, I'm building a variable, what do I intend to put in this guy? We're not just randomly putting variables out there for our health. It's like, well, how many variables am I going to need for this program? 8. Well, why 8? Probably use them. Right? That's not the way it works. We want to have our variables name something reasonable and all that jazz. All right, so some of that stuff all kind of makes sense, connecting some dots from the semester. Okay, so in any case, Python generates this fake main thing for us. We didn't have to write it ourselves if we didn't want to. So it generates this this variable called underscore underscore name underscore underscore. And if it happens to be equal to main, which is the very first thing that the Python program calls, then my program will start right here, which supports this thing right here. All programs begin and end with main. If you've ever used the tools for writing, we've been doing Unity stuff, or you're writing Android stuff. Have you seen main in Unity at all?
No.
Okay. How many of you have ever done anything with Android? Nobody in here?
On their phones.
No, not the apps, but writing the apps for your phones. Okay. I won't say you'll never see main. You have to hunt for it. The thing is true for Unity. The thing is true for iOS programming with Xcode. The same thing is true for Unity programming with Android Studio. Main exists, but they've given you this framework that your Android app kind of runs on top of. And somewhere in that framework, there's a main method that calls this guy, that calls this guy, that calls this guy, that finally calls the first guy you've written. Does that make sense? So in Android, you have to choose which of your activities is the launch activity. That tells main which guy to finally call after it does the I'm setting up your Android to run your app. Which is the first screen of your app? That guy. Okay, I'll call him when I'm done doing my magical setup stuff. So main's still there. Just because you didn't see it, just because you didn't write it, doesn't mean it wasn't still there. That makes some sense? Any modern programming language will have main in it at some level because they all came from C. And maybe in 50 years, there'll be some other newfangled language that comes out that will have a different conversation. And I think that's a real possibility because this is kind of an interesting conversation. Why might something supplant the idea of C as the core language? What's happening in computing today that might change kind of the nature of our programming languages? I still believe that most of our languages in the future will still be based on C because your army of programmers are familiar with syntax that is C-like syntax. So you kind of need to keep them on the hook to convince them to go over to the dark side. But we're really seeing a change in our way our technology works today, right? How many of you have heard of quantum computing? Okay, what is quantum computing, or is it just a cool name for something stupid?
It's where you can be both. Is electrons, right?
The who?
You can be 0 or 1 state or both at the same
Yeah.
time.
So when we think about digital logic, it's more complicated than that, but if we dumb it down to just the base core difference, when we think about digital logic, which is our computers today, things are either a 0 or a 1. With quantum, we're adding a third state, both. 0, 1, or both. Now that changes the way we have to think about solving problems. Does that make sense? Now at the same time, when you start having hardware specifically built for this, you start getting programs that are way, 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 way faster. But right now it's for very specific tasks that can leverage that new, let's call it new logic. Kind of like new math, whatever they're teaching in elementary school now. Okay? But if we presume that's going to be the next thing, in 15 or 20 years, every one of us are going to be sitting here with a laptop or a tablet or whatever that's based on quantum computing concepts. So the way we'll think about things might be different, and the way the programming languages are written, the way we problem solve might be a little different, but I still suspect they'll look like C to drag us over to that side of the fence. Does that make some sense? Okay. So technology changes. I think we had this conversation earlier in the semester as well when we talked about Microsoft Windows. Microsoft once upon a time probably had, 98% of the desktop market. Now maybe it has 93% of the desktop market because, they just lost their shine.
They're still making plenty of money.
Oh, they're all making plenty of money. Okay, but the point is Microsoft ever going to lose its dominance in the desktop market? No. What's going to happen is the desktop market is no longer going to be something it's used. We're already seeing this move towards the mobile market, right? Lots and lots of people they're replacing their desktops with laptops. They're replacing their laptops with tablets or Chromebooks, things that aren't based on Windows or the Mac OS. Mm-hmm. They're based on new types of operating systems that have kind of the mobile, some touch and swipe stuff in mind, not necessarily keyboard and mouse, or only sometimes keyboard and mouse. That's kind of the Microsoft Surface Book type of approach to things. So we're in a time where there's this transition to new ways of being productive. Does that make sense? We're still stuck in some of the old ways. So if you're a programmer, you still got to use either a desktop machine or a laptop that's running a desktop. But that's not going to be forever. Fast forward 5 years, you might be sitting in a Starbucks with an iPad or an Android tablet, or maybe some other guy, whoever the next cool tablet is, programming on a tablet. Everything's visual. You drag and drop this stuff over here and whatever it is. So Microsoft won't lose its shine there. Just as the first person to make a bicycle probably never lost their I'm guessing maybe it was Schwinn or something. Who knows? They never lost their dominance in the bicycle market. Bicycles just stopped being a mode of transportation. Now they're a recreation tool, right? All right. Questions, comments, concerns, bribes. Okay. No homework for what day is today? Wednesday?
Yes.
There's always a threat of a quiz every class, but I don't anticipate giving you a quiz on Friday. But you should still always, always, always review Slack. Do keep your eye on Slack for additional information about the presentations next week. I encourage all of you to make it a priority to come to as many of those as possible. All right?